In this video, we're going to look at subsets, proper subsets, and the empty set. Use the sets U, A, B, C, D, and E as defined below to answer the questions. So we recall that we use capital letters to name sets, and in this case our elements happen to be lowercase letters. So we can see what elements are in each set by the letters listed in the brackets. So let's review a few definitions first. A is a subset of B if every element in A is also in B. A is a proper subset of B if A is a subset of B, so that means it meets the previous requirement, but we also require that A is not equal to B. So we could write here A may equal B. It's not required to. But with a subset, the two sets could be equal, and with a proper subset, they're definitely not equal. Now, one way to remember this relationship or an idea behind it is the prefix sub, one of its meanings is part, a part of something. So A is a subset of B. That would mean that if you took all of the elements in A, it's part of B. Okay, so all of them are in B. Okay. And then finally, the empty set, which we use this symbol, a 0 with a slash through it, is the unique set that does not contain any elements. So the empty set is kind of like the 0 of sets. The number of elements in it is 0. And we say there's one such set, and we call it the empty set. So let's look at our first question. Which sets are proper subsets of U? Okay, so again, if they're proper subsets, that means that all of their elements are in U, but the set itself isn't equal to U. Okay, so proper subset, they can't be equal. So let's take a look. First, I'd like you to notice an idea that's very useful. Notice U has 10 elements, the first 10 letters in the alphabet. All of the other sets have less elements than that. So that means they could in fact be proper subsets of U. If they had the same number of elements as U, or if they had more elements, then they couldn't be a part of it because parts are less than the whole. Okay. So let's take a look at A, the set A. So the set A has elements A, C, D, I, and J. So let's look at U and highlight these elements if it's in U. So U has A, C, D, I, and J. And notice there's other elements there that are not in A, so it is a proper subset. Okay, so let's put A in our list. Okay. Now, is B a subset of U? Well, B contains A, D, E. I'll highlight them yellow now. A, D, E, H, I, and J. So all of the elements in B are also in U. Let's write this with a pen. So both A and B are proper subsets of U. And if we continue on, let's try to be a little bit more, instead of systematic, we'll try to use general ideas. So we know U has all the letters from A to J. C has the set C has the letters A and C. Well, those are letters from A to J, so C is a proper subset. D has the letters A, D, E, H, I, J. Those are all letters between A and J, so D is a proper subset of U. And E has the letters H, A, and J. Again, all of those are in U. Now, U is not a proper subset of U because U equals itself. So U is a subset of U. Every set is a subset of itself because it has all the same elements, but it doesn't have that extra requirement that the sets are not equal. Okay, so all of the sets except for U itself are proper subsets of U. Let's look at the next one. In Part B, we're asked two questions. Is A a proper subset of C? And also, is C a proper subset of A? So notice we're looking at the relationship of proper subset, but they reverse the order, okay? And remember, you can always kind of substitute, not exactly, but think of the word part, okay? Is A a part of C? Okay, so looking at A has more elements than C. There's no way it could be a part of it because it's bigger, okay? Officially, we could use this idea, is every element in A in C? And we could say, well, there's an element D that's in A and it's not in C, so it's not a proper subset. So let's write that. A is not a proper subset of C. Now let's look at the other direction. Is C a proper subset of A? Okay, so to determine this, we're going to look at the set C, look at its elements, and check each element and see if it's also in the set A. So here, the first element in the set C is the lowercase letter a. Notice that's also in the set A. The other element in the set C is the lowercase letter c, and that's also in the set A. So A also has other letters that are not in C, so these two sets are not equal. So we can conclude that C is a proper subset of A. In Part C, we're also asked two questions. Is B a subset of D? And is B a proper subset of D? So notice this didn't rearrange the set order in the statements like the last one. It's asking us two things, the subset relationship and the proper subset relationship. So I've listed B and D here, and you may not have noticed in the original lists on top, but when you line them up, you can see that B and D have the same exact elements. So that means B and D are actually equal. So we would say B, the set B equals the set D. Well, we know that with subsets, A and B may be equal, or in this case, B can equal D, and that's okay. So B is a subset of D. But is B a proper subset of D? And proper subsets require that the two sets not be equal. So we can conclude that B is a subset of D. However, let's write this in red. B is not a proper subset of D. Let's look at the next one. Part D asks, E is a proper set of which sets? Proper subset, of which sets? So let's do this systematically. So first let's locate the set E, and notice the set E has three elements, A, H, and J. And we want to check to see if it's a proper subset of all the sets listed. Okay, and you'll find quicker ways to do this over time, but again, we're going to be systematic to make sure we check each one carefully. So let's go to the set U, and we're going to look, does U have the elements A, H, and J? And we actually did this in Part A, but we'll do it again anyway. And I'm going to highlight, you could highlight, circle, whatever you need to do. The elements A, H, and J are in U. Okay, so that means E is a subset of U. And again, proper subset, there's other elements, so it's also a proper subset. So we'll list U down here. Next, let's look at the set A. It has the element A. It does not have the element H, so we could actually stop there, but we'll also highlight J. Okay, so E, the set E, is not a part or a subset of A because there's an element in E that's not in A. So E is not a subset or a proper subset of A. Let's look at B. Does B have the element A? Yes, it does. It has H and it has J. It also has additional elements, so that means it's a proper subset. So E is a subset of B. And also note, in the last problem, we found that B and D were actually equal sets. So that means we also know E is a proper subset of D. So we can add B and D to our lists. And now we'll look at the set C. Does it have the elements in E? Well, it has less elements, so you could stop there if you want, but I'm going to look at all of them. The element A is in C, but the elements H and J are not in C. Okay? So E is not a subset of C. Okay? And finally, we know that every set is a subset of itself, but we were asked for proper subsets. E is not a proper subset of itself, so our final answer is just the three sets U, B, and D. Okay. Finally, for the last question, the empty set is a proper subset of which sets? Okay. Now, it's convention to say that the empty set is a subset or a proper subset of all non-empty sets. Okay, so this is convention, so we can list all of the sets U, A, B, C, D, and E. So this is an exercise in basically a definition or a fact that of the way that sets and subsets are defined. The empty set is a subset of all sets. Okay, it's not a proper subset of itself, but it's a proper subset of any set with at least one element.